I'm now going to show you how to use a signal to move a vehicle. This can be very helpful if you want your vehicle to work with a PLC. To get started, let's select our mobile robot. Now go to the Modeling tab. In the Behaviors drop-down menu here, I'll add a Boolean signal behavior. I'll now connect my signal to my script because whenever the value of the signal changes, the script can get that notification. In the Properties panel, I will expand the Connections list and add the Python script as a connection. In the script, I'll get a handle for the signal. Alright, signal equals com.getBehavior. The name of the signal in the component is Boolean signal. And in our script, we don't need to detach the wagons or offset the vehicle's matrix, so we can delete these lines of code. And before we tell the vehicle to go to point 1 and point 2, let's wait for the value of our signal to be true. So I will use the trigger condition method imported from VC script. Now use a lambda operator to create a quick function for testing if the signal's value is equal to true. So now the vehicle will not go to point 1 and point 2 until the value of our signal is true, and this condition will only be tested when there's a trigger to our script. In this case, our trigger is a signal that we connected to the Python script. Let's compile our code, and if I run the simulation, you can see nothing happens. That's because we have not turned the value of the signal to true. An easy way to do that is to connect the signal to a port in the robot and have the robot signal the vehicle to move. So let's go to the Program tab, and now I'll use the jog command to select the robot. In the Connect group, I'll click Signals to use the Connect Signals command. This allows me to wire a connection between the Boolean signal in my mobile robot to a port in the robot. Let's wire the Boolean signal in the mobile robot as an output of the robot and change its output port to be 100. There we go. You can quickly verify this in the Connect Signals task pane. So in our Signals column, let's click the gear icon and filter only connected signals in the robot. So the output port of 100, you can see, is connected to the Boolean signal in the mobile robot. Now, you don't have to write any statements in the robot's program to test this. For example, if I run the simulation, you can see the value of the signal connected to the output port of 100 in the robot. It's actually false right now, or undefined. But the benefit of the Connect Signals task pane is you actually can toggle the value of a signal. So I can click this orange circle here, and now it's true, and now the vehicle's moving. So let's see that again. Reset, run the simulation. Our signal is not true, so the vehicle is still not moving. But now let's use the Connect Signals task pane to toggle its value to be true, and now our vehicle is moving. Let's reset and go back to our script. Let's take a somewhat different approach. Instead of using a trigger condition, let's comment out this line and use a suspend run method that we're importing from VC script. So now, after this method is called, the rest of our onRun event that we defined here, this will not be executed until we resume the run. An easy way to do that is to use the onSignal event. So in our script, let's define onSignal. This will give you the signal that triggers this event. So when our Boolean signal here that we connected to our script, when its value is changed, we'll get that notification. So from here, we'll just call if signal.value is equal to true, colon. Let's call the resume run method. And this is also being called from or imported from VC script. So it should be resume run. There we go. So now we're using the suspend run to pause the onRun event we defined in our script. And then we're resuming it once the value of the signal is true. So compile the code. And let's run our simulation. Nothing's happening because we have not signaled the vehicle yet. Let's go to our Connect Signals task pane and set the value of the signal connected to output port 100 in the robot to true. And yep, we get the same result. The vehicle is now moving. I'll reset the simulation, and let's take a somewhat different approach. Instead of resuming the run and suspending it, let's create a queue or work order for our vehicle. So I'll comment out the suspend run And now before we use the events, let's create some variables. Instead of having the points defined in the onRun event, let's cut these lines of code here. And we don't need our for loop anymore, so let's delete everything down here. And then at the top, let's paste in our 2 points. Oops, I got rid of them actually. That's okay. I'll just press the Control+Z key to get everything back. There we go. So let's copy or cut all this. We don't need the trigger condition and suspend run anymore, so I will actually just delete that by pressing the delete key. And then at the top, I'll paste in my code. I need to fix the indentation, so I'll select it and press the Shift key and Tab to move it back to the left. We don't need the for loop. Let's delete that. And now for our point 1 and point 2, let's create a new list called route that contains those 2 points. So point 1 and point 2. Let's now create a queue variable that is an empty list. And at the start of the simulation and the onRun, let's set our queue to be an empty list by using this line of code here. And whenever we get a signal, instead of resuming the run, let's add a route to our queue list. So queue.append route. And then what we can do in our onRun event is create a loop. I'll use the application object, so I'll write app equals get application. Let's make the script a bit bigger. And then while the application.simulation object is running, so we're creating a loop that will check if the simulation is running. And if we have an item in our queue list, this will return a true value, so then we want the vehicle to use that route or follow that path. So I'll say path equals queue.pop. This will give me the last item in a list. Then we'll say for the position or point in the path, let's use our vehicle object to add the control points, like so. Now if we don't have anything in our queue, we have to create a delay so we don't have an infinite loop. So let's use a delay of 0.1. And to quickly review, we defined 2 points for the vehicle, point 1 and point 2. We created a route list to contain those points. Whenever we get the signal connected to our script, its value is true, we're going to add that route to a list called queue. At the start of our simulation, the queue is empty, but then we created a loop. So while the simulation is running, we're going to check if there is an item or job in the queue. We'll then get the path that's in the queue and tell our vehicle to follow that path. Otherwise, we'll just loop back and keep checking. Compile the code. Let's minimize our script and check the output panel real quick. It's empty, so it's fine. Let's now run our simulation, and nothing's happening because the value of our Boolean signal is still false. Let's now use the connect signals task pane to set it to true. And yep, we get the same result, the vehicle's moving. Let's now reset and go back to our script. And instead of using the while loop, we can just remove this, or let's just comment it out. You can keep it for future reference. Because if you don't want to use a loop, we can go up here to our onSignal event, and instead of adding the route to a queue, let's comment this out. Let's just define the path of the vehicle from here. So we have to get the vehicle object as a handler. So once again, I'll say comp equals get component equals comp.getBehavior. Name is vehicle. With these two tasks here, or sorry, these two lines of code for your component object and your vehicle behavior, you could make them global if you wanted to. But just to give you a simple test case, let's now use the vehicle with a for loop. So for p in route, you can see here that contains point 1 and point 2. We'll add the control points. I don't believe this is time consuming, so it should work in the onSignal event. Let's try. So once the signal value is true, we're going to tell the vehicle to go to point 1 and point 2. Compile the code, minimize the script, check your output panel. It's error free, so that's good. Run the simulation, nothing's happening, so let's now turn the Boolean signal value to true. And yep, we get the same result. So that's just a couple of ways you can signal the vehicle to move where you want it to in the 3D world. Instead of using the robot, we can use some other components. I'll reset. And now let's go back to our Home tab. In our eCatalog panel, under Models by Type, let's use some component templates. I'll add a feeder template to the 3D world. Let's now add a conveyor template and connect it to our feeder. Zoom in. And let's run our simulation. You can see the feeder creates these parts, these cylinders, and they move along the conveyor's path. So let's say that when a part reaches the end of the conveyor's path, we want to signal our vehicle to go to some location here. So let's reset. And with the conveyor template selected, I'll go to the Modeling tab. Let's now add a sensor to our conveyor. So I'll add a component path sensor. Let's now put the sensor at the out frame of our path. So in the Properties panel, I'll set the frame to out frame for our path sensor. We also need a signal for our vehicle. I'll go back to Behaviors drop-down menu and add a Boolean signal. In our Component Graph panel, let's select our component path sensor. And then the Properties panel will use that Boolean signal. And now, let's go back to the Connect group here. Click Signals. Let's now select our mobile robot. And I'm going to click the wire here to disconnect the mobile robot's Boolean signal from the port in the robot. And now connect it to the Boolean signal in the conveyor template. So now our vehicle will go to a point when the conveyor tells it or sets the value to true. So the mobile robot knows to go somewhere else. And where do we want it to go? Let's have it go to some frame that's to the side here. So I'll select the conveyor, then go to your Component Graph panel, and make sure you're working in the root node. You could also just double-click the feature to select its node, in this case the root node of the component. I'll now add a new frame feature. Let's now move the frame to about 290 or somewhere to the side here of your conveyor, near the end of its path. You can see. I'll now rename the frame to be pickup location. And then when we get the signal, let's tell our vehicle to go to this location here. So to make it quick and easy, let's use our existing script for our mobile robot. So we got the points here, but we don't need them anymore. I will delete this stuff. And for our onSignal, let's get rid of this. We don't need our loop anymore. We can delete that. So now we just have the vehicle defined, our onSignal event. So let's create some global variables real quick. I'll get the application object, so app equals get application. I'll again get my conveyor, so I'll use the application object to find the conveyor as a component. The conveyor's name is straight conveyor template, I believe. Then let's get the frame in the conveyor, so frame equals conveyor. That get feature. We are pretty much doing exactly what we did in some earlier videos. We're getting that pickup location frame. The point we need to go to, let's get the world position matrix of our conveyor. So conveyor.world position matrix. Let's now get the no position matrix of our frame in the conveyor. So npm equals frame.no position matrix. And then our point is the world position matrix times the no position matrix of the frame. And then when the signal value is true in the onSignal event, let's tell our vehicle to go to that location. So let's actually take our component, our signal, and our vehicle, and let's move these to make them global. So I'll cut and paste, fix the indentation, and just create some white space here. Then when our signal value is true, let's use the vehicle object to add the control point of that frame feature in the conveyor. So add control point, point. Let's now quickly review. Move my script over here. We added a feeder and conveyor to the 3D world. and define a location where we want the vehicle to go when it receives a signal from the conveyor. That signal will be sent to the vehicle when a part moves along the conveyor's path and triggers a sensor located here at the out frame. If we review our script, we've got a handle for the conveyor and the frame feature that's the pickup location where the vehicle has to move to. We then define the point of the pickup location, but we can notice an error here. A recurring issue is that we're defining this as a matrix, but it has to be a vector. So I will put parentheses around my point's position matrix and get its p attribute, which is its position vector, and then that point will be added to the vehicle's path when we get the signal from the conveyor. Let's compile our code, minimize our script, and if we run the simulation, you'll see that nothing happens. That's because we still have to make some adjustments to our conveyor. Let's reset. Double click the conveyor to select its root node. If we now go to the component graph panel, we have to connect our component path sensor to the path itself. So select the path, and then in the properties panel, expand the sensors list here, and then add the component path sensor to the path. So now our sensor is connected to the path and can detect parts on the path. If we go back to the connect signals command and review the task pane, let's first select our mobile robot. We can see the connection between the mobile robot and the conveyor. If we run the simulation, right now the signal value is undefined or false, but once a part is there, we can see, yep, now the vehicle is going to that path, or that pickup location here. Let's now reset. And if you don't want the parts on the path to exit, what you can do is let's exit out of our connect signals command. Select the conveyor again. In the component graph panel, let's select its path again, its path behavior. And if we expand it, it has these two ports. So the input port is for transferring components into the path. The output port is for transferring components out of the path. So let's select the output port here, and then in the properties panel, let's clear the output checkbox here. So now the vehicle will transfer in parts, but they won't be transferred out. Run the simulation. And yep, the part stops at the end of the path, and they just keep on stacking up, and here comes the vehicle to pick up these parts. Let's pause the simulation. And what we'll do in the next video is teach our mobile robot to grab or transfer these parts from the conveyor into its own container or path.